Okay, Psych 213, this is our first lecture. Now, as you can see from the slide here, our notes or our material really begins here with habituation, but there are some topics I want to just give you a quick overview of, and that's the purpose of this particular video. So this is day one kind of stuff where we talk about what is learning, right? And learning is the process of acquiring information, or a better definition might be a relatively permanent change in behavior as a result of some experience. And if you think about it, when we are talking about learning, we have to measure it. So that would be a theoretical definition, what I just gave you, but we have to sort of operationalize it, define it in the laboratory, like what is learning when we sort of see it. And it often, when we measure it, depends on memory, right? So we would say you've learned something when you remember it, right? So we could give you a list of words and ask you to recall those words. That would be called recall. Or we could have you study a list of words and then present to you a mixed list of old and new words. And you tell us which ones are old, which ones are new. That would be recognition memory. We could show you some words, delete some of the letters, creating a word fragment, and have you complete those word fragments. And we could look at all kinds of things, right? This is only limited by our imagination, but we could look at accuracy, we could look at errors, we could look at response time, how quickly you respond. And one of the things that happens is that you respond faster, or when you respond faster, is evidence that you've learned something. We could look at response rate, which is the number of responses over time. And early in this class, we're going to be focusing a lot on response rate when we talk about animal learning. We could also look at savings. That is how quickly you are to relearn some information. So maybe you haven't studied calculus in several years, but you could relearn that topic if you take a calculus class. And that relearning or faster relearning rate is something called savings. So we could measure learning in all different kinds of ways, but it's always going to involve memory. So learning and memory are kind of inexplicably combined in terms of topics. Now in this course, we're going to focus a lot on the learning aspect of things early in the course, and then we'll focus a lot on the human memory aspect of things later in the course. But another topic that's related that we won't spend a lot of time on, or hardly any time on in this class, it's always there kind of in the background, is motivation. Because motivation is our cause of actions, right? It's factors that drive our behavior. And so if you think about it, we're not going to learn unless we're motivated for some reason to learn, right? There has to be a reason to learn. There could be external reasons or extrinsic reasons, sometimes is the term that's called. So maybe you're learning for grades or to earn more money or to earn a diploma. These would be extrinsic reasons. Intrinsic reasons would be something like, I just like the material. I'm interested in this topic and I want to learn on my own. So we could break motivational forces into extrinsic or intrinsic kinds. Generally, I'm just going to boil things down for you. These, like I said, motivation is going to be there in the background the entire semester. But generally, we're motivated, humans and animals, by the way, generally motivated to seek reinforcing events, and avoid aversive events. So avoid aversive or unpleasant events. And so these are, again, concepts we're going to dive into and talk a lot more about as the semester unfolds. So why should we study these topics? Well, if you think about it, they're very central to our behavior. We can't perform new tasks or cope with our daily life without some form of learning. We wouldn't do anything, eat, drink, live without motivation. And we can't learn without memory. We have to be able to retain information from the past in order to change our behavior in the future. So these are really important topics to everything we do every day. So to give you a little bit of an overview of some of the thinking on this, it really begins with the ancient philosophers. So they thought a lot about memory. They wrote a lot about memory, and some of the observations were quite good. And during this time, there was a book called the Rhetorica ad Herennium. We'll learn about this book as the semester unfolds, but it taught students how to use their memory to remember all kinds of information, including the textbooks that they were studying. So in this time before the printing press, if they came across a book, they may never see it again. So they had to memorize the entire book. I wonder if you can imagine sort of doing that. But our story is going to start with Ebbinghaus in terms of empirical data collection. So this begins with Ebbinghaus in 1885. He generated forgetting curves. So when we talk about forgetting, we'll come back to Ebbinghaus. And he's largely credited with being the sort of the first memory researcher. Thorndike 1898, studied the puzzle box, and what he studied was trial and error learning. So here's a picture of a puzzle box here. So this is the box, and you can see that there's a cat placed in the box. And you put the cat in the box, and you shut the door, and anybody who knows cats is they don't like to be confined in boxes unless they get in the box themselves. So you put the cat in, you shut the door, and they want to get out of the box. Well, the animal can get out of the box if it pulls on a string that's hidden inside this box here. If it pulls on the string, it'll activate this trap door, and the trap door will open, and the animal can escape. Here you can see the time that it took the animal to escape. So early in the course of being in the puzzle box, Thorndike observed the behavior and found that the cats just did random sorts of things and learned through trial and error, and eventually learned how to escape, and they would escape pretty quickly, as you can see the time dropping off in this graph. Now, Thorndike's trial and error learning applies to all kinds of things. I have an example here from our other dog, Dozer. So Dozer died a few years ago, but when Owen was young, he put a tennis ball in one of these expandable ball things, and over again, eventually, Dozer figured out how to get the ball out quite efficiently. So here you're going to see a video of Dozer with the ball coming out quite efficiently because he's learned through trial and error learning. There we go. Okay, so we're getting ready to put the tennis ball in.
No, not yet. Stop it. Really. Wait. Desert. Okay.
Get the ball. So you see he grabbed the ball pretty quickly through trial and error learning. So we'll also talk about Pavlov, 1928, classical conditioning, right? So he learned or discovered by accident that stimuli can be associated. So food would elicit this response, and tuning fork is neutral, it doesn't. But eventually, with enough pairings, the tuning fork does elicit that response, that classical conditioning. So we have lecture 2 is classical conditioning. We'll talk about Pavlov and that form of learning in a lot of detail. And then Watson and Skinner and others, the behaviorists, started talking about operant conditioning. And this is where the animal operates on the environment. So the classic example is a rat in what's called a Skinner operant box, pressing a bar for a food pellet. So we'll learn how all this works, but they were able to study behavior in a different way, different form of behavior, and study it in a different way. Now, the other thing that was happening here is Skinner, and in particular, was suppressed sort of research on mental events, things that happened inside the quote-unquote black box, right? And he suppressed research on this because he said we can't observe these events. We should stick to observing behavior that we can actually see, right? So this continued for many years, and a lot of the learning theorists didn't really talk about mental events, so no emotion or motion research was suppressed, memory research was suppressed. Lots of these areas of research were suppressed until the cognitive revolution in the 1960s, when researchers decided to study the black box, or events that happen in the black box. So we can study memory. We can study things that we can't observe. Nobody's ever seen a memory, but we can infer its existence, right? We can infer that if your behavior changes, that there's some evidence of memory. It makes it really tricky. It's very difficult because we can't observe it, but we can do it. It's just much more complex. So what's the current state of learning? So learning is not an active research area like the other areas of psychology, like biopsychology or cognitive psychology or abnormal psychology. It's not alive like those. It exists in the sense that general learning principles or laws have been sort of developed, and we're going to talk about those. And these principles work. We use them to shape our own behavior and others around us. So whether it's other people or other animals, and by the way, animals use them on us. I have lots of examples as the semester unfolds that you'll sort of see that. So they really work. So knowing how these things work, you can control other people's behavior a little bit better. The other thing is that learning is now applied. So we use learning, animals in particular, to study drug effects like psychopharmacology. We study neuroscience by observing animal models. We also apply it to teach children, to train animals, things like that. So there's all these useful sort of applied versions of it, but as a field, it's not exactly current and alive and vibrant anymore. Now, the other thing I like to talk about on day one is I get questions from students, can I improve my memory? And the simple answer to this question is yes, you can improve your memory. Couple of steps though, it's not just as easy as snapping your fingers. The first step is you have to believe that you can change your memory. And now the reason I say that is a lot of times people think memory is just a state, right? Something you're born with. So they say like, oh, I have a good memory or I have a bad memory. That's not true. Memory is a skill that you can develop, you can hone it, you can make it better. You can also make it worse, depending on what you're doing. So how can you make it better? Well, these are things that we're going to learn over the course of the semester. By the way, these steps that I'm going to talk about here, steps 2 through 4 here, are detailed more on your syllabus, and we'll flesh them out as we go through the semester. But the first thing you can do is set a routine for your improvement. Use classical and operant conditioning to shape and mold your behavior. You can do this to improve your concentration, so you can focus a little bit better for longer periods of time. You can start with small periods of time and gradually increase it. That's shaping. You can sleep better, have a better sleep pattern. You can exercise more. Exercise helps your cognition as well. So doing these things help you become a better receiver for information. Then when you're studying, employ effective learning strategies. We'll learn about these too as the semester goes on. So elaborate the information, use some generation, organize the information, space out your studying. So smaller bouts of studying spaced out is much more effective than a large or same length study time all crammed together. That will really help. The other thing you can do is minimize distractions while you're studying. And one of the biggest distractions we have these days are our phones. And so to study this, I had a student who was interested in this, and he wanted to know how much do phones sort of distract us. So what we did is we did a study, an event-related potential study. That means recording brain activity while people were doing a task. And they were doing a task in our laboratory that demanded a lot of attention. And we recorded the ERPs. This is the signal from the brain. This black line is sort of when they were doing the task without distraction. And then we had them do the task again when they were using their smartphone. That's sort of this brownish red line here. And we measured how much of a drop in this ERP, this measure of brain activity that we got. And in the first study, 45 to 48%. Now we did another study where we changed the task and we did a gambling task and we found similar results here. Now the important thing about this is in this gambling task, it was a self-paced task. So people were able to sort of control the information flow. We still saw that phones were sort of dropping their available cognitive resources by about half. So you're kind of like half the person you are when you have your phone and when you're using it. So if you really want to get the most out of your brain, put your phone away as you're studying, particularly. Minimize your distractions. Now the fourth step is practice, practice, practice. Practice using these techniques. Practice shaping your behavior. So we're going to talk about this, and this is going to be part of what your course does for you over the course of the semester. But practice, practice, practice using these techniques, good effective techniques to improve your memory, and you can see lots of improvements if you follow those steps. Now, the other thing I like to talk about in day one is ethics in animal research, because we're going to be talking, particularly the first half of the class, we're going to be talking about studies that involve animals in research, and I know that some people are morally opposed to using animals in research. And I don't necessarily want to change people's opinions, but I do at least want to give you good, clear information so you understand what must happen before we can test animals. So if you're going to do animal research, that requires IACUC approval. So IACUC stands for Institutional Animal Care and Use Committee. And so they review your proposal and approve it or tell you to make some changes to that. A couple key things here is that the membership includes a veterinarian and an outside person, somebody with no known ties to the institution. And these people exist on this committee because if there were some research that were happening that were unethical, they would be free to blow the whistle and essentially turn over the scientist who was conducting unethical research, right? So that's what that is. Now, the animal care and use is governed by the Animal Welfare Act of 1966. So that's right, animals are protected by federal law. So if you abuse animals while doing research, you are in violation of federal law. You can go to prison. And by the way, this Welfare Act includes husbandry for all kinds of animals that are part of our food chain. That would, on farms and things like that, they have to be cared for in certain ways up to code. Now, researchers must present evidence to the IACUC that the study will generate novel information. So this is a higher threshold, right? You have to show that the information is not there and it's going to be valuable, scientifically valuable information. You don't have to do this for human research. You can do replication studies in human research just to demonstrate that the effects exist again. But with animal research, that's no go, right? The idea is the animals are giving their time, their lives for this research, so it has to be productive, right? It can't just be to cover old ground. The other thing the researcher must do is that if there's any pain and suffering, it must be minimized. Or if you are using pain and suffering, it has to be justified, meaning that there is no other alternative. And that's a pretty high bar that's on the researcher to prove to the committee that that in fact is the case. There's no other alternative. Now, there's a lot of information out there, and some of it is a distortion of reality. So I want to talk a little bit about my experiences. I have experiences with animal research at 3 different institutions over the last 30 years. And I want to give you a sense of what I've learned from that. So if we're talking about the learning studies in our class, we're talking about ones that only use mild or temporary pain or discomfort. So really the animals, laboratory animals, have a really good life in terms of like they're working for food and things like that, but they're generally happier and healthier than animals out in the wild. The other thing is the ill or injured animals is counterproductive to science. So even if you want to believe that the scientist doesn't care about animals, they would care about their science. Otherwise, why are they doing the research study? And to have ill or injured animals, that's counterproductive to you being able to get good data on animal behavior. It's just not representative of what you're trying to study. The other thing in my experience is that most animal researchers are animal lovers. Think about it. You gravitate to what you love, right? What you enjoy. Why would you work with animals if you hated them? Most people would go into a different direction in a different field and not test animals. It's pretty much just that simple. So in my experience, these people care about these animals like they care about their pets. Most of the species that we're talking about are considered pests, right? So a lot of times we're going to be talking about rats, or the most modal studied animal in psychology for behavior purposes these days. And if you had rats in your house or apartment, you would call an exterminator to kill them. So at least we're getting something from their lives. We're studying behavior, we're studying the nervous system, whatever it is that we're studying, and we're getting valuable information. These animals, the other thing I want to point out is these animals get weighed and they get inspected each day. They're seen regularly by a vet. So they get better health care than you, at least in the United States of America. Not everybody gets health care. These research animals do. So that's better for you. Now I'm going to talk more about in class. I'll talk about this experience with University of Georgia, which gives you a sense of where priorities lie for an institution. But it's better than some of the materials may make it out to be. So this is where our notes kind of begin, really start. We're going to talk about our first basic form of learning, which is called habituation. You might also see it called sensitization in some texts. But habituation is a decrease in response. So the behavior is diminishing over time in response to a stimulus. So a stimulus can be anything, a sight, a sound, anything the animal can detect or the person can detect. So it's a decrease in response to a stimulus as a result of repeated exposure. So, for example, like you might be exposed to a loud sound, it might cause you to jump or flinch. But if you're continually exposed to that loud sound over time, your jumping, your flinching will diminish. In effect, you're learning not to respond. You're learning that that stimulus doesn't really do anything in your environment, so it can be ignored, so it doesn't demand any kind of response. So I'm going to end this video here and have you, in a link in Canvas, you're going to watch a video example of an animal undergoing habituation training. So as you watch this video, because I don't own the rights to this, I can't include it in this video, but as you watch this video, try to look at the animal's behavior and try to match it to that definition. And when you come back to part 2, we'll talk a little bit about that video and what you saw.